Welcome to Debugger's team. Are you a 10th grade student? Do you study matrices? Do you have problems with multiplying matrices by vectors? Do you like computer programming? Then we welcome aboard. In this video we will show you how to multiply matrix by a vector using Python. Now theoretically, in order to solve a matrix vector multiplication, you need to do the following. For a matrix M equals 2, 1, 2, 3, 2, 3, 4, 1, 1. These three are called columns. And this is a matrix. Originally it came from M11, M12, M13, M21, M22, M23, M31, M32, M33, from left to right. And the vector V equals V1, V2, V3, 1, 0, 1 in our example. It is called element, this is called element, and it originally came from V1, V2, and V3. Number of elements must be equal to the number of columns in the matrix. Then in order to multiply M by V, the following formula is to be used. M by V, M11 multiply V1 plus M12 multiply V2 plus M13 multiply V3, M21 multiply V1 plus M22 multiply V2 plus M23 multiply V3, M31 multiply V1 plus M32 multiply V2, M33 multiply V3 plus. If we use an example, M equals 2, 1, 2, 3, 2, 3, 4, 1, 1 multiply V equals 1, 0, 1. M multiply V equals 2 multiply 1 plus 1 multiply 0 plus 2 multiply 1 C plus 1 multiply 1 plus 2 multiply 0 C multiply 1 4 multiply 1 plus 1 multiply 0 plus 1 multiply 1 equals 4, 6, 5. Tough, isn't it? Especially if the matrix is greater with more complex numbers using Python. We can solve this and other examples in one step. Just develop the right code and start vector matrixing. In order to solve a matrix multiplication by a vector using Python, first step, open a Python sheet. Second step, develop the function. Third step, dealing with the lists. Fourth step, multiplying M and V lists in Python. Fifth step, use loops to repeat process. Sixth step, add the right produced values in one list. Seventh step, add the right produced values to each other. Eighth and last step, return the final answer. First step, open a new Python sheet as follows. Second step, develop the function. Here we define a multiply function of M, which is matrix, and V, which is vector, stands for vector. In order to write the matrix in a Python format, we will divide it into three Python lists as follows. If M of M11, M12, M13, M21, M22, M23, M31, M32, M33, we'll divide it into three lists with M11, M12, M13 in a list, M21, M22, M23 in a list, and M31, M32, M33 in a list, where the M matrix, the B, is converted into a big list called list of lists, and the three small lists are inside it. Convert the vector V into a Python list as follows. V equals V1, V2, V3. In Python it will be a list containing V1, V2, and V3. Third step, dealing with lists. We need to separate the M list into small lists in the Python way as follows. m equals m of 1 1, m1 2, m1 3, m2 1, m2 2, m2 3, m3 1, m3 2, m. This is m of 0, this is m of 1, this is m of 2, this is m of len of m minus 1. The number of lists can be determined using len function, which is used to determine the length of lists. Len m in our case equals to 3. Our example, the index of first list is always 0, m of 0, second list m of 1, the index of this list is always the last list m of len m minus 1. The code shall be as follows. Fourth step, multiplying m and v lists in Python. We need to multiply the items as follows. m11, m12, m13, m31, m22, m23, m31, m32, m33 multiply v1, v2, v3 equals m11 multiply v1 plus m12 multiply v2 plus m13 multiply v3, m21 multiply v1 plus m22 multiply v2 plus m23 multiply v3 plus m13 multiply v1 plus m32 multiply v2 plus m33 multiply v3. In the above, we need to calculate each one solely. In Python, we just need to develop the right code works for calculation as follows. In our code, we need to access each element in each list of small ones. For example, for the first matrix, m of 1, 1, m11. In order to access this element alone, use m of 0 of 0. m12 consequently is m of 0 of 1. m13 will be m of 0 of 2. Note v equals v1, v2, v3, where v1 equals v of 0 and the last is v of 1 and v of 2. Therefore, the first multiplication we use m of 0 multiply v of 0. Note both zeros, v of 0 and 0 of 0. The two numbers increase, n equals len v times according to the number of columns in the matrix, which is equals to number of elements in v. This number only changes once at the same period of time. These other two numbers change. In order to make this calculation with one equation where I changes for any iteration and repeat again for each iteration where j changes, we need to use loops. We set I equals 0, j equals 0. The code will be as follows. Fifth step, use loops to repeat process. We need two loops. One repeats itself with the change of j value and the other one repeats itself for n times in each change of j value. The loops shall be as follows. J changes according to the length of the matrix ln m, which is m in our case. M is the number of small lists in the big matrix. We access first each small list, then access each element in that list. Next to go to the next list to access the first small list, we use the following while j less than m. Then to access the elements inside the small list, we use the following while j less than m, while I less than n. Then we add our multiplication equation, h equals m of j of I multiply v of I. Now we have to increase the value of I by 1 for each iteration. While j less than m, while I less than n, h equals m of j of I multiply v of I equals I plus 1. Now we have to increase the value of j after finishing I's while loop. J equals j plus 1. Note this j equals j plus 1 must be outside the while loop. If used inside the while loop, it will increase by n multiply m, while actually it needs to be increased by m value only. The loops shall look like while j less than m, while I less than n, h equals m of j of I multiply v of I equals I plus 1, j equals j plus 1 outside the second while loop and inside the first while loop. Now I must be set to I equals 0 again, since the loop will be started doing the same number of iterations again. Either use I of 0 outside the two loops and then use I of 0 again outside the second loop only and inside the first loop, where I of equals 0 will be assigned 2 times, or use assign the I after the first while loop. We need here to assign I for one time only. We select the second case because we do not need to assign the same variable with the same value 2 times or more than 1. Our code now shall look like. Sixth step, add the right produced values into one new list. In order to add the produced values to each other, we do the following. assign a new empty list to a variable. For an example, L equals empty list, and the value of the H in a list equals list of H. Now add list of H to L, forming a new list, bigger. L equals L plus list of H. The output shall be as follows. L equals M11 plus multiply V1, M12 multiply V2, M13 multiply V3, M21 multiply V1, M22 multiply V2, M23 multiply V3, M31 multiply V1, M32 multiply V2, M33 multiply V3, till MNN multiply VNN. Our code now looks like this follows. Seventh step, add the right produced values to each other. This is the most tricky step in the process. We need to add each consecutive n number of elements and add them into a new list that shall contain the final values. The code must be developed to perform this step wherever the number of small lists was and wherever the number of elements in the list is. We need to access the new L list, group each n number of elements together and add them, and then put them into a new list. The following steps shall be followed. 1. We need to make a while loop so as to access the index of all the elements in the L list. Second, the next step is to develop an index interval for the list starting at the first index number and ending after exactly n numbers from the first index. Then access all the elements inside the created interval each at a time, then adding the elements inside the interval to each other. This needs to be to develop for a for loop in order to access all the elements inside the list, but limited to the interval size. Then when exiting the for loop and returning to the while loop, we need to skip n numbers of elements and access the index number of the previous value plus n. The coming line shows us how to translate this in Python language to us. We need to make a while loop so as to access the index of all elements inside the L list. W equals 0 while W less than len of L. Next step is to develop an index interval for the list starting at first index number and ending after exactly n numbers from the first index list. W equals 0, H equals 0 while W less than len of L. This new interval is H to W. Then access all the elements inside the created interval each at a time. To do so, we use L of H till W. Then adding the elements inside the interval to each other. This needs to develop a for loop in order to access all the elements inside the list, but limited to the interval size. W equals 0, H equals 0 while W less than n of L. W equals W plus n, S equals 0 for K in L of HH. W, S equals S plus K. We use the same trick of adding the variable to a variable equals 0 so as to add the values to each other. Then when exiting the for loop and returning to the while loop, we need to skip n number of elements and access the index number of the previous value plus n. W equals 0, H equals 0 while W less than n of L. W equals W plus n, S equals 0 for K in L of HH to W, S equals S plus K, H equals HH plus n. We increase this plus n values with n and n value, and we increase this also of n value so as to the interval size remains constant. The code now is as follows. 8th step and the last one is to return the final value. The last step is to do the same trick of assigning an empty list to a variable, then adding the summed values in a list and adding both lists in the empty list as follows. We shall call it answer in this empty list and adding answer equals answer plus list of S. The last step is to return the answer outside all loops as follows. Return answer. The final code is as follows. Thank you for watching our video tutorial.